Hi, my name is Kurt Niebuhr. I am a principal PM on the Azure HPC team. Spent a lot of my time working with automotive customers, specifically on the autonomous workloads, and been asked today to kind of talk about some of the cool stuff we're doing in this space. First, people, they always ask, like, Azure, why are you even in this space? You're not making any autonomous vehicles. And actually, because we're not making autonomous vehicles, that's exactly why we're in this space. We see, autonomous driving as, the ultimate AI problem. And but more than that, autonomous driving represents a shift from a mechanical engineering centric workflow to a software centric workflow. And we, Microsoft, see ourselves as a software company and a software platform that is very much focused on enabling our customers' partners to do this digital transformation. And that's exactly why we're in this space. In other words, we are very much focused on using our platform to help customers basically make some of the coolest things on planet Earth, inclusive of autonomous vehicles, and that's why we're in this space. So, but having said that, autonomous driving is, it's a tough problem to deal with. You're basically trying to solve the largest AI problem, that mankind's, tried to tackle to date. You have a bunch of sensors packed on a car that have to perceive the world around it. They have to follow policy, like following with the car, a certain distance in front of them, not hit people, process all this data, and make decisions in near real time. So training that autonomy stack basically requires our customers to be able to do three things very well at scale. First is they have to be able to scale, their CI/CD pipeline, Azure DevOps. Second, they have to be able to scale their AI training, which is basically what we call, ML ops. And third, and this is definitely where our partner ecosystem plays a key role, is you have to be able to scale your validation pipelines. And last but not least, you have to be able to integrate your DevOps, your ML ops, and your validation pipelines. So basically those swim lanes of all the different engineers all collaborate in a very meaningful way to, basically bring these products to market faster. So the autonomous driving end-to-end workflow is a very, complex workflow. We call it the data loop, where you basically start with test vehicles. You probably see them driving all over the streets. See things like the LiDAR on top with a big camera, kind of driving around. So it starts with those test vehicles where we pull all the data out of those test vehicles. Then we have a series of very large compute jobs, right? And then at the end, you need to send out the updated, software and algorithms back out to the vehicle for more tests. So because you starts with the vehicle, goes back to the vehicle, we call it the test loop. So we basically look to support that end-to-end workflow. So today, I would kind of like to discuss, where we think we're very differentiated in some of the compute intensive aspects of this. I would like to say, though, we are also, extremely strong in some of the other aspects. For example, DevOps. And then some of our storage solutions in the space. But seeing how I'm on the HPC team, I'm going to talk about what some of the cool stuff we do in the compute space. So first, I think one challenge we're very much focused on nailing is what we call resimulation or recompute. Resimulation and recompute is probably one of the more challenging jobs to figure out how to do, because very often customers use either a very specific or custom application or an application that is supplied by the in-vehicle SoC, that's system on a chip company. So like something from NVIDIA or Mobileye or Qualcomm, and they basically have to recreate and assess, what happened in the test vehicle. So you basically take all this data out of the car, and it's this really large, embarrassingly parallel test where you basically score the performance of the test vehicle during the test drive. And the reason you want to do that, and you want to be able to do that really accurately, is because you have to figure out what software or what AI algorithms need to be updated. However, it's key to point out that you're not really doing anything new or adding any new capabilities to the car as a part of this job. You're simply saying, okay, did that test drive go well? And because of this, the low value added of this job per se, there's like huge demands to run this in a super cost performant way. So we've spent now several years inside Microsoft, working on basically SKU design, optimizing our applications, be it Cycle Cloud or Batch, to run these jobs in a very cost-performant way, okay, and get very linear scaling, so you can get past this job and then get the results then to the software developers, to the data scientists, so you can do this, open this what we call the data loop, execute it even faster. So resimulation and recompute continues to be an area where we'll invest going forward. Another area that's really huge is simulation. Simulation within the world of autonomous vehicles is a little different than traditional simulation, because you have new scenarios that need to be validated. So we call it, we basically break it into two major buckets specific to autonomous driving. One is the validation of the sensors. Okay, in other words, perception, right? In other words, the lidars, or the cameras, all the radars that are on the car, did they actually see the world? They were the way they're supposed to see them. Did they see them accurately? Maybe did sunlight or did something else mess with it? And did it affect the performance of the vehicle? That's one type of sensor simulation that you take. Another one is scenarios or post-perception, okay, which is basically policy. Like, is the car following at like a proper distance of the car in front of it? Did it navigate the traffic circle well? When it say executed some sort of a maneuver like an overtake, did it keep distance? Did it keep between the lanes when it got there? Did all those types of like policy driven things that when you drive yourself, you never think about, but if you're going to have a robot do it, you really have to validate all these capabilities. And then, of course, third is, we just call it engineering simulation, or even performance simulation, which is basically traditional HPC. But if you think about it, autonomous vehicles, you're going to have to do all the same types of simulation you've done to date, be it your crash test, your wind tunnel, like CFD jobs. But there's also, a lot of other jobs, especially multi-physics jobs. There's like NVH, noise, vibration, harshness, other types of jobs. When a computer or a robot is driving for you, people are going to basically want to do infotainment. So we expect that there's going to be a huge, massive new types of simulations for the purpose of like occupancy, the occupants in the vehicle, what they will want to experience as they ride around in these autonomous vehicles. So simulation, we expect to continue to be an exploding opportunity for us on Azure, because let's face it, the amount of simulation that has to be done is just crazy huge, and so it's an exciting opportunity for us. And a last one, the third one that I want to talk about in our limited time today, is some of the unique requirements when it comes to large scale compute that we have to accommodate for, and I would call that hill rig integration. Hill rigs, hardware in the loop, is a very specific type of testing that is done on very specialized and custom rigs in what's called hill farms inside automotive companies. And it is very clear to note that these, for functional safety and certification, these some of these ISO or compliance mandated workloads, it must run on this types of specialized equipment. You can't run it on a regular VM, which puts it on us, Microsoft, to figure out a way how to integrate in a hybrid way with these specialized compute systems between our VMs and the cloud. And there's multiple ways we can do that. One is just simply on-premise and cloud orchestration of this hybrid type approach. Another one is in partnership with companies like Equinix, where we put it in a colo and then integrate between the two, and basically obviate the need for all those egress costs. Going forward in the future, in close partnership with a sister team of mine in Azure, the Azure dedicated team, we're also even looking at ways of bringing this specialized hardware into Azure, much like we do today with our program with Cray supercomputers. So, in closing, I would like to just remind everyone, this is very much a partner driven type of engagement. Although we in Azure and Microsoft, we do have first-party services that are critical to the success of us in the our success in the space. For example, Azure DevOps or MLOps. The entire, that third pipeline, the validation pipeline, is completely partner-driven. And we have many, many amazing partners and reference customers in this space who we are deeply partnered with, because it's very much a domain that requires a lot of expertise that we, Microsoft, don't have, but we do bring the ability to help these partners scale their business and scale specifically their capabilities. And that's really, at the end of the day, really lights up the scenario for a lot of our customers. So once again, Microsoft, we are very committed to this space. We believe we're really contributing a lot to the innovation here, and would definitely like to continue to work with customers and partners here to really make this digital transformation happen. Thank you.